Hi, this is January 2019, Unit 1. So, number 1. An object has an acceleration of 6 meter per second at an angle of 30 degree to the horizontal. Which of the following expressions give the horizontal component of acceleration in meter per second? So, we have a line to the horizontal and 30 degree to the vertical, 30 degree to the horizontal, and the object has an acceleration of 6 meter per second squared to this direction. So what is the horizontal component? So if we draw a right angle triangle, we need to find this. So we have hypotenuse and we have the adjacent. So hypotenuse by adjacent is cos. So cos 30 is equals to adjacent by hypotenuse 6. So the value of x would be cos 30 degrees into 6. The answer to this question is A. If it was saying that which of the expressions give the vertical component, then we would have this 6 sine 30, since the vertical component would be this length and opposite by hypotenuse is sine, so we would have to use sine 30 in that case. Number 2, a graph of stress against strain is plotted for steel. So a graph for stress against strain, so the graph would look like this. So it says that which of the following is equal to the Young's modulus of steel. So this would be stress. In the y-axis we would have stress here, and in the x-axis we would have strain in this direction, and this is the limit of proportionality, this is the elastic limit, and this is the yield point. So which of the following is equal to the Young modulus of steel? So from the syllabus we know that the Young modulus is equals to stress by strain. So stress by strain is actually the gradient of the graph. So the gradient of the graph up to the limit of proportionality. Why the limit of proportionality? It is because up to the limit of proportionality, this is a straight line. Up to the limit of proportionality there is a straight line, and since there is a straight line there will be a constant gradient. So since there is a constant gradient, there would be a constant Young's modulus. So the answer would be D. Answer would not be A, because A is saying that up to the limit of area under the graph up to the limit of proportionality. So up to the limit of proportionality it is the energy stored. So if we have like this, and if we try to measure the area under the graph, this area this area would give the area represented is the energy which the spring is taken in. So A is not the correct answer. B is not the correct answer, because up to that point it represents the work done. Work done is equals to force into distance. Force into distance is work done, and stress into strain is also work done, since it is basically the force into distance, and so this represents the work done, not the Young's modulus. And C is not the correct answer, because it is up to the elastic limit. So after the limit of proportionality we have the elastic limit. So before it hits the elastic limit, the line is not a straight anymore. The straight line is not there anymore, so the gradient of the graph will change, so the Young's modulus won't be the same. So the answer to this question would be D. Number 3. The work surface in a kitchen is made from marble. Marble is suitable for this use because it is brittle. So brittle is a property in which an object breaks easily. So this is not the reason. Ductile is a property in which a material becomes permanently deformed and a tensile force is applied, so B is not correct. C, hard. So hard is correct because in kitchen we use the work surface of a kitchen for slicing meat or slicing vegetables or so. We use a knife, right? So when we use a knife, there would be scratches in the surface, and hardness is basically the property which resists scratch or indentation on the surface. So C is the answer. D is not the answer because D is basically malleable, and malleable is a property in which there is a permanent deformation due to a compressive force. So working surface should not have a permanent deformation when a force is applied. It is the least wanted property in a work surface. So the answer to this question is C. Number 4. A ball is thrown vertically upwards with an initial velocity of 20 meter per second. So we have a ground level here, and a ball is thrown upwards at 20 meter per second, and an equation of motion is used to calculate the time taken to move a displacement of 15 meter. So 15 meter is basically, for example, this would be 15 meter. So the ball is initially directed upwards at 20 meter per second, and when it is at the topmost point, the displacement from the ground is 15 meter. So we can say that we can use the SUVAT equation, SUVAT, where S is the displacement, U is the initial velocity, V is the final velocity, A is the acceleration, and T is time. And we have a displacement of 15 meter, and we have an initial velocity of 20 meter per second, and when it has traveled 15 meters, the final velocity would be 0, since the ball would go like this and fall again on the ground. So at this point the velocity is 0, so the final velocity would be 0 meter per second. And since the direction is upwards, the velocity direction is upwards, and there is a deceleration, there is a resultant force acting downwards, so in the opposite direction. So since it is in the opposite direction, we will use the opposite sign. So instead of the gravity G, we would use minus G as acceleration. So the equation relating S, U, V and A is S equals to ut plus half at squared. So S is 15 equals to U is 20, and time is half into minus G into T squared. So the only answer that matches with this is option C. So option C is the answer for number 4. Number 5. So before I start, if these videos are helping, please let me know by liking the video or commenting. These will motivate me to make further videos to help you guys. So number 5. Quantities can be either scalar or vector. So what are scalar quantities? Scalar quantities are those quantities which only have magnitude but do not have direction. For example, speed, for example, time. There can be 5 meter per second, 10 meter per second, or 5 seconds, 10 seconds, 15 seconds, 1200 seconds. So these do not have any direction, they only have speed. But what is a vector quantity? A vector quantity is the one that has both magnitude and direction. So the example would be velocity. So an object may be moving at 5 meter per second due north or due south or due east or 30 degrees due west. So the velocity may be 5 meter per second, 30 degrees due east. So velocity is a vector quantity since it has both magnitude and direction. So which row of the table is correct? So we have density and velocity. Density is a scalar quantity since density equals to mass by volume. Mass is a scalar quantity and volume is also a scalar quantity since it has only magnitude but no direction. But density is also a scalar quantity because these two are scalar quantities. The left hand side would also be a scalar quantity. And velocity is a vector quantity since it has a direction. It is because velocity equals to displacement by time or direction by time. So direction is a vector quantity and time is a scalar quantity, so velocity would be a vector quantity. So the answer to this question is C. Number 6. A toy car moved down a slope and 1.5 joules of gravitational potential energy was transferred. The toy car gained 1.2 joules of kinetic energy. Which of the following could be used to calculate the work done against frictional forces acting on the toy car from the information above? So these are related to energy, right? We have 1.5 joules of gravitational potential energy, and when it is moving down a slope, so a slope may be like this. There is a car and the car is moving downwards, and for example, this is the height. We have the height over here, which might be this one, H. So GPE, gravitational potential energy, is equals to mgh. So this mgh is being converted into motion. The motion means there is velocity, and since there is velocity, there is ke, kinetic energy, equals to half mv squared, since there is a velocity. So since there is a velocity, the velocity would be converted from the gravitational potential energy. So part A says that Newton's laws of motion. So the Newton's laws of motion only deal with forces and acceleration, since Newton's laws, for example, F equals to ma, F equals to del p by t, or Newton's third law, everything deals with forces and motion and acceleration and things like that. It does not concern energy. B. The equations of uniformly accelerated motion. So this relates to the Suvat equation, for example, V equals to U plus AT, S equals to UT plus half AT square, something like that. So this also does not concern energy. Part C says the equation work done equals to force into distance. We do not have distance in the question, so distance and force are not given in the question, so we cannot use this. Part D, the principles of conservation of energy, we can use this because the gravitational potential energy, the total GPE, is equals to ke plus the energy lost as friction or as light energy or heat and sound, anything, the energy lost. So if we have 1.5 here and 1.2 here, the energy lost would be 0.3 joules. So this is correct. We can use the principles of conservation of energy, which states that the energy can neither be created or destroyed. It can be only converted from one form to another. So the answer to this question is D. Number 7. The diagram represents two forces acting on an object. So this is one force and it became a heart. So this is one force and this is another force. So these two are forces and these two have a resultant force. So we have a force in this direction and a force in this direction. So we can use a head tail method. For example, we can join the head of this line with the tail of this line, or the opposite. So let us join the tail of this line with the head of this line. So if we take this line, we have this line over here, and if we take this line over here, we can see that this tail will be going to this head now. So if we join the tail and the head like this, we have the resultant force like this. We always have to join one tail of a line to the other head of the line. So the answer similar is D. In option C is also similar, but the line is in the wrong direction here. So the answer to this question is D, since this line has all the required directions corrected. Number 9. A stationary uniform ladder leans against a smooth wall as shown. The ground is rough. So it should be providing a friction on the ladder. So this is the wall, and this is the ladder, and this is the ground. Which of the following diagrams show the forces acting on the ladder? So this might be the wall, and this is the ground, and this is the ladder. So if this is the ladder is exerting a force on the wall in this direction. So due to Newton's third law, the wall will be exerting an equal and opposite force on the ladder in this direction. And similarly, there is a weight of the ladder downwards, and the ladder will be pushing on the ground on this direction. So since the ground is rough, there will be an equal and opposite force on this direction from the ground on the ladder, and there is another force which is due to the weight. The ladder will be exerting a downward force on the ground, so the downward force will be like this, and the ground will exert an equal and opposite force upwards on the ladder. So the forces on the ladder are this one, this one, this one, and this one. So this is similar to option C, so this is correct. Another way we can find out that every other answer is incorrect, because we see that here the horizontal components cancel out, but the vertical component does not cancel out. There is a resultant force upwards. In this scenario, the vertical components cancel out, but the horizontal component does not. So there is a resultant force in this direction in option D, and so for these we can conclude that the correct answer to this question is C, since it says that the forces acting on the ladder, not on the ground. So the correct answer to this question is C. Number 10. A particle is falling through a fluid at terminal velocity. So terminal velocity is basically a constant velocity when the resultant force is zero. For example, for a parachute, there is a weight, downwards weight, and as speed increases, the air resistance increases till the point when the weight is equals to the air resistance. So at this point, when the weight is equal to the air resistance, the resultant force is zero, and since the resultant force is zero, since we have the formula F equals to ma, when the resultant force is zero, the acceleration will also be zero. Since the acceleration is zero, there will be no change in velocity, and since there is a no change in velocity, it is moving at a constant velocity known as terminal velocity. So in a terminal velocity, the particle is accelerating. So it is not true, because the particle acceleration is zero. Part B says that the velocity of the particle is zero. No, the velocity is not zero. The change in velocity is zero, but the velocity, there is a velocity which is constant. The change in velocity, which is the acceleration, is zero, so B is not also correct. There is a resultant force on the particle. So there is no resultant force, since I told you that all the vector sum of all the forces will be equal to zero, so the resultant force will be zero. So the answer would be option D. Option D says there is more than one force acting on the particle. The answer is a bit vague, but it is true, since if there is only one force, there won't be any opposing force downwards, or if there is a force rightwards, there should be an opposing force on the opposite direction. So in this case, there should be more than one force which would cancel out the other force. So the option is D.